Hi guys, welcome to PhysChem with Liz. I'm Liz, and in this video we're going to look at calculating an enthalpy change from combustion data. Now this is my second video on Hess's Law, on worked examples. If you haven't already, please watch my video on using formation data because I go through it in slightly more detail there. And I also have an introductory video on Hess's Law if you need to recap the basics first. So here we have some enthalpies of combustion for different molecules. So we've got ethene, ethane and hydrogen, and we're given this balanced equation in the question. And what we want to calculate is the energy change on getting from here to here. So remember from the introductory video, when we're given combustion data, this is the Hess cycle that we draw. Our arrows point down and we have combustion products here. Now, we don't even have to write what the combustion products are, unless it specifically says so in the question. We can just write the words combustion products. But if we're burning hydrocarbons, it's going to be carbon dioxide and water. Okay, so the next thing we do is we label route 1 and route 2. So you can see that these two arrows are going in the same direction. So let's label this route 1. And we have this arrow that's going counterclockwise in a different direction to those. So we can label it route 2. The next thing we do is collect our terms. So we write the expression. Hess's law says that route 1 is equal to route 2. And we collect all the terms involved in route 1 first. So we've got the delta H that we want to find out. And we've got the ethane. So the value for that is minus 1560. And we write it equal to the terms involved in route 2. So we've got the ethene, minus 1411, plus the hydrogen, minus 286. We work this out on our calculator, this side first. Then we rearrange in terms of delta H. And we take, to isolate delta H, we take this over to the right hand side, it becomes positive 1560. So let's work that out on the calculator. I'm going to do this on the camera. Okay. So open bracket minus 1411, close bracket, plus minus 286 equals minus 1697. So this here comes to minus 1697. We take this to the right hand side and it becomes positive 1560. We work that out and we get our final answer for our enthalpy change. So minus 1697 plus 1560 minus 137 kilojoules per mole. And that is our answer. So that was just a quick worked example on how to calculate an enthalpy change for a reaction using combustion data. I hope that was helpful. If it was, please like and subscribe. Thank you.